Good evening and welcome to another session of the Niger You Drive 2025 Free Digital Skills Training, sponsored by IHS Towers and implemented by OVL Foundation and Kratos Sustainability Consult. So we've been on the data science track and we've been exploring a whole lot from the introduction to Python programming down to machine learning. Okay, so my name is Abayomi Okunola, joining from NASA 84 Lab. And last class, we took a look at supervised learning. And we mentioned that supervised learning is subdivided into two. We have the regression task as well as the classification task. So regression is used to predict continuous values, while classification is when you want to predict discrete outputs. Say, for instance, you want to predict yes or no, true or false. While for the continuous is, say, you want to predict sales price, that's value, it's continuous that way. And we mentioned that first thing first, before you say you want to delve into a problem, you need to first of all look at what is the business problem, what is it about, what's the data that will be required before you proceed to do your data cleansing, your data modeling, and then you go on to the evaluation, and then finally to the deployment stage. Okay, so here right now we want to continue. So here we have in the previous class we showed us the particular machine learning libraries we'll be making use of, right? And I think I shared something on the group chat this evening, a Twitter shorts where they said what's the big three, and the big three are what? The first one there is import pandas as PD, import numpy as NP, import matplotlib as PLT. Okay, so before you begin to add your machine learning model, so you need to first of all work on the basics. Okay, all right, so going forward, we've installed pandas, we've installed numpy, scikit-learn, which is our machine learning library, and then matplotlib for data visualization. So you can see the big three were first imported here. Then here we're making use of a decision tree regressor. We had to upload our data sets, right? So this is just a recap. We looked at data validation. We checked out for the properties of the data sets with df.info. The shape gives us, so this is the certain amount of rows and the certain amount of columns. Then we proceeded to say, okay, we are working on a regression task. That is, we only want to select numeric columns. So that is what we did here, select only numeric based columns, and we brought out the subset here. Then we decided to do our data splitting where we have the X and the Y. And I mentioned that your X are your explanatory variable, while your Y is the target variable, also known as X is what? Independent variable, while your Y is your dependent variable. So depending, you might give it a whole lot of names, but still ensure that you mean the same thing. So you can see your target here as the price. Then we decided to classify the variable here. And then for the splitting, we made use of the train test split function. All right, and we said our test size here is 20%. So we can always catch up on that. So for here, we took a look at the data shape to see if this function actually worked right. So you can always look back at the previous video to catch up. Then we moved on to model selection. Okay, so before diving into any problem, understanding the problem is very, very important. What type of problem am I solving? How do I go about it? Is it regression or classification? If you've established that, then you need to begin with the common or the basic algorithms. Okay, and the basic algorithms in terms that just use them with the default parameters. So for instance, if I should over on this linear regression right now, so like I mentioned, you can always read up documentations online. Okay, so let me run all and see what have. We have so I'm trying to over on this linear regression, so it could bring out the documentation. So do we have any questions even up to the recap, so we can take that now while this running is done? Do we have questions? Right to assess why it's not running. I think it's network EU. Okay, it's running now. All right, so let's go down. Do we have any questions? Question. Okay, so I take your silence as no question. Oh, so this is requesting that this particular file is not in memory. Okay, so this is another thing entirely.
Hello, good evening. Please, when are we getting the? Can you hear me? Hello, good evening.
Good
Please, when are we
evening.
getting the third class for this one? Like the voice record, like the YouTube one you sent to us through the link.
Please check your email. Okay,
Okay.
so let me upload the file for this, and okay, I still have it on this machine.
Yes. Okay,
Okay,
thank you.
so this is one thing. Maybe I'll just try and look at
Yes.
how we can link our data set from Google. So, so instead of having to upload on the runtime every time. Okay, so let me just run this down. Okay, so now we have the linear regression here now. So you can see it has the default parameters here: fit, intercept, boolean. Default is true. You want to copy your X, the number of jobs. So do not worry yourself about all this right now at the moment. Okay, so you can always read through. So we've initiated our linear regression using default parameters here. Then we fit it to our data set. So now the model has been fitted. Okay, then next thing we want to do is we want to make predictions on our test set. Recall, so the test set is that part of the data set that the model has not learned from. Okay, so here we have the values for our Y prediction. So let's convert this to a data frame. So this is our Y test originally. Then if we should convert our Y prediction to a data frame right now, so you can see what's giving us. It's really far. Okay, so next thing is, how do we evaluate a model's performance? So model evaluation is very important. It helps you to know, is my model doing very well, or it's not working very well? So this is very important. So how do you evaluate? It's just like saying, how do you know that, okay, this particular model actually did well? Okay, so the first, so for regression, the model evaluation is different from that of classification. So for regression, you have your mean square error, you have your mean absolute error, and then you also have the root mean square error. You also have the R squared, which is the coefficient of determination. So for the mean squared error, that's the average of the square differences between the predicted and the actual values. Please stay muted. So your mean square error, like I mentioned earlier, is the average of the squared differences between the predicted and the actual value. And it penalizes larger errors more heavily due to the squaring. So there's a squaring that happens. So the function had already been written. So you do not need to, but you can still code it out yourself. It's a mathematical formula. I can share that with you later on. Then we have the mean absolute error. So the mean absolute error is the average of the absolute difference between the predicted and the actual value. However, this is less sensitive to outliers compared to the mean squared error. Recall I was mentioning something about outliers that they would really impact your data. I mean, when it comes to your model training and evaluation. Because say for instance, you want to take data for secondary school students right now, knowing fully well that the age range is between say 12 to like 16, 17, or 18. Let's say 12 to 18. Okay. However, now you are seeing 120 as the age of someone in secondary school. You ought to be what? You ought to look into that. How possible is this? So errors might come in during the data entry stage. Okay. So you need to clean that up. That is very important. And then lastly, here we have the root mean squared error. So the root mean squared is just like you have your mean squared error already. So when you apply a square root to it, okay, so it brings the error back to the original unit of the target variable. So that's just it, basically. Then we also have the r squared. So this one comes in value. So it will be like 0.1, 0.2, 0.4, 0.5, such that a value that is closer to 1 indicates that, okay, the model actually performed very well. So we are going to look at each and every one of them. Okay. So now the formula for this mean squared error, it has already been built. So let me walk us through where we did the importation. So here right now, you can see we said from sklearn.metrics import mean absolute error and then mean squared error. All right, so this is where we imported the metrics import evaluation metrics. All right, so let's go back here. So let's see. So here we said MSC equals to mean squared error. You open your brackets, y predicted, and then your y test. So you want to measure between the differences between your predicted value and then the original value that you had. I mean, the source data that you collected to see how the model is performing. So you can see this difference is really wide. Let's take a look at the mean absolute error. This is 1,127,483. Wow. Okay, so let's take a look at say the r squared. Let's see if the r squared is gonna perform well. Okay, I have my y bad. Okay, so y tests. Okay, no, I didn't call r2. Okay, so this is about 0.54, and recall I mentioned that when it's closer to 1, it indicates a good fit. So the mean absolute error between the actual value and the predicted value, you can see this range is very wide. So you might need to look into that and say, oh, what is actually happening to this model? So you still need to go back and do further exploratory data analysis, which is EDA. Okay, so say for instance now you apply your model now and you are seeing that okay, the difference between the predicted and the test value is just like say maybe a difference of say like 5, 6, 7. I mean in figures right now you can know that okay, this model is actually performing very well, and then you might need to what, look into it to ensure that it fits very well. Okay, so also there is a concept of underfitting and overfitting. So I won't be boring you much with that. Okay, so we can always read up on that while we proceed. But if time permits, we might take a look at that in office hours or so. Okay. Hello, are we here?
Yes.
All right. So when it comes to the okay, should I proceed? Okay, so when it comes to overfitting now, that means the model learned the training data very well. Okay, including even the outliers and all that you have. While underfitting would be the model didn't even learn enough about the data set. So it's kind of perform both poorly on the training and the test data. So such that even as you proceed on in your journey, you would see instead of these two splitting that we did, you are gonna have like three splits. You have your training data set, you have your validation data set, then you have your test data set. But for the basics, start with this. Okay, just split into two. You have your training data and then your test data. Okay, so earlier on we took a look at numeric uh, data. Okay, so now let's proceed with categorical data. How do we work with categorical data sets? So recall we didn't get any error earlier on. We're just cruising and cruising because the computer only understands what? Numbers, numeric, right? It doesn't understand all these furnished, semi-furnished. So you need to transform it into what the programming language can understand. Okay. So first thing first, let's take a look at the unique values in for main road. So for main road here, you can see it has two unique values which are yes or no. Okay, so if I should do the same for guest room now, you're gonna see that for guest room as well, it's also a yes or no. All right, so let's check for furnishing status. So I'm sure you'll be like, wow, which other format is this guy writing this thing this evening? He didn't bring it in a square bracket and all. Okay, so like I mentioned in one of the classes, if there is a space between this furnishing and status, okay, then you need to ensure that what it's being quoted right and it has your inverted comma. So this is what you need to do. All right, so you quote this now. So if I should run this now, you see that it still gave me the same result as this. Why? Because this one is best used when your feature is having a space in between or all, but nevertheless, because this one doesn't have any space between, so that was why it was able to work through that way. So let's note these best practices even as we proceed. And another thing I want you to notice is that when you are writing your code, it might be very, very funny sometimes. Okay, so for instance, a colleague was trying to run a code, and because of one underscore, he had to spend time. He was running the code, he wasn't giving any error, applied some try and if and try function, try and accept error functions and all. The code was running, it didn't give the expected output. What could this be? Not knowing that what an underscore was behind the issue. So let's take note of all these little things before we as we proceed. All right, so we want to see which particular data sets with categorical variables now. So recall earlier on when you say your df.info. Okay, so what do you have? You can see you have main road, guest room, basement, hot water heating, air conditioning, furnishing status, and pref area as what as object. So let's run this now. It's going to tell us, so you can see we have a list of the data, I mean the features with an object feature which are strings. Okay, so if you take a look at your pref area right now, you can see it also contains yes or no. We've already done this one earlier on, which is the furnishing status. Okay, so now we want to have our categorical data. So just like we applied earlier on, we had to create a list to bring out that categorical data set. So we said categorical data equals to list. So this one that we have here already, so we just tell it that okay, we want a list right now. So on running this, you can see we now have a list. Instead of what we had here, we're having an index, the type is object. So right now we have it as a list. We have our headers as a list. So here we now need to implement our for loop. So for loop, how does it work? So you can always check back at our previous classes. Okay, so for your item in your list of values, what function do you want it to perform? So instead of you saying, oh, do this thing for me once, instead of writing the code 1111, so once you give it to a for loop, it will run through the process for you and deliver the same result. So we said, okay, if you are picking the first one, we say for main road in categorical data, you say the column main road has the following categories. Then it's going to print the data frame and then unique. Recall what we did earlier here. So the data frame and then the column name dot unique. So this is what this is gonna do. On running it now, you see the column main road the first one, main road, has the following categories, yes or no. While for the other ones, guest room, basement, hot water heating, air conditioning, pref area, and furnishing status now has about 3 categories. Okay, so now we can't push this to our ML model. What do we need to do? We need to format them. We need to transform these features. Okay, so there are many ways to do this. One is through mapping. So mapping is going to be, you are going to manually encode the values such that you can say, okay, yes is 1, 0 is no. If it's for say sex or gender right now, you say okay, 1 is female, 2 is male. So you need to encode it into what? Numeric features. So how do you encode? You use the dictionary mapping. Okay, so you use what we call the dictionary mapping. So here we said, oh, convert each unique value into integer format. We said assign yes as 1 and no as 0. Okay, assign yes as 1 and no as 0. That's what we want to do now. So we now created our dictionary mapping here. So you can also use the replace function whereby you be coding it one by one. But since we want to apply this for, we have 1, 2, 3, 4, 5, 6 columns that are yes or no. So it's just better we just use that mapping. So I'm sure you remember your dictionary. You have your key, right? And then you have your value. All right, so we called df main road, that is the existing data set. Okay, So let me even bring this up now. Let me print our DF here so you can see. Can you see how it's looking like right now? You're still having this, all this here. Recall our first few rows. So we're gonna do something now and compare. Let me explain this first. We said, okay, our main roadmap is gonna be yes as 1, no as 0. So we now called the original data frame. So we want to replace it in its entirety now. Will be equals to the current data frame dot replace. Then you put your map for basement, for hot water, for air conditioning, pref area, and guest room as well. You use the dot replace and then you map it according to this. Okay, so after that,
Hello,
then
I can't see your screen. Hello, I can't
uh
see your screen.
okay, can anyone else see my screen so we can know if it's a network issue at your end?
I can see a screen.
Okay, so please rejoin Abisola. Okay, thank you for that. So for the furnishing status now, because it has three values, 3 unique values, so we need to create another map for it. It says furnished status map. We have your furnished to be 2, semi-furnished as 1, unfurnished to be 0. Okay, but how did we even get to know that, okay, it's yes and 1 and these are what we have? So it's due to what? Checking out the unique values we have. So you can see that if you have thousands and maybe you have hundreds of features right now and you have a whole lot of them as categorical column, that can be very, very what? Boring to start what? Mapping them one after the other. And in cases whereby the cardinality of such columns is very, very high, so you need to what? Remap them. I mean, remapping in terms of uh say for instance now, you want to classify people based on their age. You say, okay, maybe this person is uh a baby, this one is a teen, this one is a young adolescent, a young adult, adults, OD or so. So but in cases whereby you have at least that one is still cool and fine, maybe like 5 or 6 categories or unique variables. But when you are having a case whereby you are seeing your unique values to be like over 10, over 15, that's too much for the machine to learn from. So you need to what? Bin them and reduce it to maybe like 4, 5, or yeah, 4, 5 is okay, depending on the project scope. That is very, very important now. Okay. So having created this furnishing map, we decided to also replace it. So let me run this now. And okay, so it's saying replace is gonna be duplicated and will be removed in a future version. So you can see now replace might be working yesterday, but when you come around today, replace is no longer working. So they said future warning that casting behavior in replace is deprecated, removed in a future version. To retain the old behavior, explicitly call this. To opt in to the future behavior, you should set your pd.option to be this. Okay, so let us tell it that we want future downwardcasting. Let's run it and see what we have. Okay, so you can see with this line of code right now, we've already silenced that error. Okay, so silent replace deprecation warning. Okay, so that was what we did now. You can see that warning did not later come up again. So you can see now that our price, everything is now what? So you can see this one, we assigned it as 2, that is furnished. And then pref area 1 is yes. So let's check the top data set. You can see 1 is yes and furnished is what is 2. So this way right now, you can say, oh, you want to proceed and give this data to your machine to learn from. Okay. Do we have any questions? Welcome, Mr. Lawson. How is training going? All right, so let's push. So our df.info, let's check now. Do we have everything as numerical? We still have object. So you can see everything is now what? Integer 64. So this way we can push. Okay. I want to check something. All right. So now let's take a look at our column names. We have our columns ready. So we recall earlier we were trying to predict what the price. So we are going to drop the price from the feature list. I mean from X. We are going to drop the price and our Y's are what? A target variable, which is Y. So here we're gonna do the subsetting, around this to memory. So let's implement our horizontal split now. Training set and test set. So who can tell me what's the current test set value? What's the percentage for the test set? Anyone? 0.2. Okay, so that's 20%. That's the value of our test set. Okay, so let's run this and let's see our results. So X test. So let me run the shape now. We have 436 to 109 for the testing. So now we want to implement another model, which is decision tree regression. Okay, so this decision tree has more trees. So it's an advanced version, like we mentioned earlier. Okay, of model, such that it's very, very simple. You can look through it. That is when it comes to the visualization. So, but not to worry. So, part of the basic model you can work with when beginning the linear regression, the decision tree, and then the random forest. So, random forest embodies more decision trees into it. Okay, before you start improving your parameters. So, we fitted this decision tree regressor to the model. So let's make a prediction of our S text. Let's predict the first 5 values. So you can see this is giving 506, 5.6 million here. Okay, so let's do the evaluation. This is giving 1263. Let's take a look at the MSC. Wow, this is still far wide apart. Okay, let's take a look at the R squared then. Let me bring this in. We have a Y test and a Y spread. So the first one we did was giving like 0.54, right? Okay, so now you can see this is giving 0.38. Let's even take them together and see. Let's see the difference. If with more features we're able to perform more and better, or the reverse was the case. Okay, so you can see for the MAE here now, we have one. This is 1 million, right? 127. This is 1,263,000. Okay, so for the MSC, this is showing about 3 million. No, this is over 3 million. This is 1, 2, 3, this is running into trillions now. Okay, so might still need to dig deep and dig further. Why is this model still not giving us the results? And please note, when you are building your models, start with the basic things. Start with the basics of basics, not to just deep dive into bigger projects. And I would recommend that you go on Cargo, sign up, and take a look at what other people are doing, and even enroll on Zindi as well. We have Zindi Africa. Enroll there, try to see what people are doing, make your own contributions as well, and learn on the go. Okay, so your model evaluation doesn't stop here. So you might still go ahead, try another type of regression model and see, does this one actually do more better? Then you compare between the models, which one to go for. Okay. And also recall, when you are trying to do that, ensure you are using the same set of data, passing it into what? The same 3 models for easy comparison. Okay. So I said I was gonna just chip in how to import data sets from Google Drive, because this session of a thing whereby you upload to session, once the session is cleared, the data set as well moves away. You need to upload again. But if you have your data on your Google Drive, you can always fetch it at any time of the day. Okay. All right. So just a quick one. How do we get to import data from Google Drive? Has any one of us tried that before now, where you loaded your data set on Google Drive and you imported it?
Sorry, sir. How do you mean data set? Like, what are the things because I think I've downloaded some things on my drive before, on my Google Drive.
Okay. Okay. So right now, for your Google Drive, you can upload files there, be it image,
Yes, yes, I
be it
have. I have
audio.
uploaded.
So now,
Exactly. Yes.
yes, so your data set means your Excel files, for instance, like CSV. Instead of you to be uploading it to the runtime, once you finish that session, I mean the Google Colab session, you close the browser, you launch it again, and then you try running the code. It will tell you that that particular file is no longer what in that
Okay.
runtime again due to the expiration of
Okay.
runtime. So, but
Yeah.
your files on your Google Drive will still be there. Okay,
Okay.
and that will actually save you a lot of issues when it comes to connecting to your data set. So, say for instance, now you have a Google form whereby you are collating responses on it. I mean, a Google sheet. Okay, you are using the Google form. The result will go to a spreadsheet. I mean, the Google Sheets, and the Google Sheet is already what embedded on your drive. So instead of you to keep downloading and uploading, so why not just connect to it directly? I hope
Okay.
you got that concept where I'm
Yeah.
trying to picture.
Yes, sir.
Okay, so how do we do that is what I just want to show us, and then we call
Okay.
it an evening. So how do we import on Google Drive? Import. So let's also make it to the office hours on Friday, where we're going to be having the wrap up. So data science class for quad 2 will be ending on Friday morning. That's the office hours. Okay, so let's just chip this in. So I hope others get to see this video and also learn. So the first thing we need to do is we say from google.colab, we're asking it to import the drive. Okay, so recall earlier here, if you open this file explorer, you'd see upload file. That means you want to upload to the session storage. But once the session has expired, the file also what goes off. Then the next one here is if you want to make a refresh. And then here you have your what? Mount drive. Okay. Then here you want to what? Show your hidden files. Okay, so now let me mount. Let's mount our drive. So we've already from Google Colab, we said you should import drive. Then let's mount Google Drive. So I would say drive dot, can see, mount. Okay, drive dot mount. So let me call, I want to mount my drive folder. Okay, so here right now I already mounted my Google Drive. So let's run this. Let's see what it gives us. So can you see what's showing on my screen? It says permit this notebook to access your Google Drive files. Granting access to Google Drive will permit code executed in the notebook to modify files in your Google Drive. Make sure to rebuke your notebook prior to allowing this access. Let's connect to Google Drive. So it's going to show you a window. So all you just need to do is, when you are trying to do single sign-in option, you get this external window telling you, are you sure you want to connect? Let me see. Okay, so I hope you can see this. Then I'll tell it that, okay, I want to continue. I want to sign in. Then you tell it, okay, continue to access. So once you give it the access, I think let me share my.
Your screen is not showing.
Okay, just a second. Okay, so now having allowed that to proceed, so you can see now I've got this. It says mounted at content/drive. That's mounted my Google Drive now. Okay, so let me expand this. So can you see something? Can you see now that, yeah, I now have what? Drive. So if I should expand this, you can see I have my drive. And if I should open my drive, you can see a whole lot of stuff I have here. So I'm seeing my Google Drive literally here right now. Okay, so what do I need to do? You can just say, okay, you want to call a part. Say for instance, Nigeria you drive now. I want to see my Python class data sets. Okay, so I want to pick a particular file here. Let's say for instance, this insurance data. Yeah, I'm sure a task was being released for us, so let's try to work on that task. So if I should just right click and say copy path here right now, notice I've copied the path. So let me paste the path here so you can see how it looks like. So now you can see. So with this right now, I have my path already. Okay, so what I just need to do is, let me say my pd.read_csv. Recall, let me say df1 equals to pd.read_csv. Then you open your brackets, you put in quotation marks your file paths. So let's go to the end. So df1.head. Let me run this. So can you see now that I have access to what? To that data set now on my Google Drive. And one thing you need to note again is the particular file you are sharing must be viewed. Okay, not to lock it and say, oh, it's having restricted access. That way you might not be able to access it. So ensure that folder is accessible for viewing purpose, or that particular file is accessible for viewing purpose. So I believe this way we've been able to see how to import our file from Google Drive. So this is very, very
Hello, sir.
important. Hello.
Sir, please, do you type that content drive or I didn't get that part?
This one.
Yes, sir.
Is it this one I'm highlighting?
Yes, sir. Yes, sir.
Yes, I was the one that typed it. I said it should mount. It should mount my Google Drive. Then on running this, then it now brought out that window, that approval window for single sign-in option to say, okay, am I requesting to sign into Google Drive? Do I want to proceed? Then I said yes. So apparently
Okay, sir. Thank you.
you can decide to break this down by doing what we call linking. Okay. So say for instance now you want to access multiple folders or multiple files in your folder. So you can just say, okay, let's define the project, maybe the project directory path now. Okay, so you can say, oh, my main parts on Google Drive is where is this guy that you have here, is this first one here, up to Drive. That's your main parts. You define that one, then you now say, okay, maybe your project parts will now be equals to your main parts, main part that you defined here, plus this other one here, which is the Niger Youths data set. This right now up to this end. Okay, so that means you want to create a link, this one plus this one. So let me even uncomment this two guys now so you can see what I'm trying to show you. So if I should say print,
Mr. Brian, sorry, sir. I
okay,
lost you while it was. I think someone asked questions, so I lost that conversation. I did not. It was not clear. It was breaking from my end.
okay, so where was the last place you
I
picked
think he
from?
was trying to say something, but I did not hear. It was just skipping from here.
Okay, so what he mentioned was this Mount Google Drive. That was I the one that typed it. So I said I had to write this as part of my code. Everything you see here, when I wrote it, then I ran it, it brought out a window
Okay.
for access approval. That okay, do you want to access Google Drive? Which services do you want to accept? So after doing all that, then it now wrote mounted the content.drive. So that was why I said when you open this file explorer now, you can see before we had only sample data announcing CSV, right? So
Yes.
but right now
Yes.
I can
We
see
have
my
drive.
Google Drive. Even
Yes.
if you over on this right now, the Google Drive is already what mounted.
Yes, sir.
Okay. So I was now trying to explain that okay, when we drill down, we're able to see that okay, we have a file path, content drive, then my drive, then I have Nigeria drive, Python class data sets, then I have insurance data set. So however, in most cases, this might be very, very long. Okay, so you need to break them down in cases whereby you need to source for data from two different file paths, okay, or
Okay.
two different
Mhm.
project directory. So you just know that okay, just this is also part of writing clean codes so that your codes do not become messy. So uh like I was mentioning, okay, so here we've defined main part, which is content or drive, then our project part as well. We said main part plus we had to do a concatenation. So if I should print this project parts now, you would see what it will give. Can you see what it returned? Let me bring this out. So it said my file part is content drive, Nigeria drive, and then Python datasets. So that means I'm only left with this last one here, which is the insurance data.csv. Okay, so how do I bring that one in? I can just say, okay, let me bring this. I would say my df1 equals to pd.read_csv, right? So I'll also do the concatenation as well. Project part plus, I can now say, okay, bring in this guy, my insurance CSV. Yeah. No, it says no file found, blah, 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 blah. Okay, why is that? Content drive, Nigeria drive, insurance data. What we loaded now is that there has been a preview on the back end. Let's rerun. Let me bring in df1.add here. Then we debug what's up. So do not always be afraid when your code throws error. Try to find out what the issue is. Let's rerun this. Is it mounted? It says drive is already mounted. Python datasets. Then the next one says no error found. So on. So let me uncomment this one and see what this one will give. La, 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 la. To check if that particular file has not been. The file is there. So what could happen? So that means there is an issue somewhere. Okay, let's take a look at this very well. We have content drive. Yes. Can anyone spot the issue now? Hello? Can anyone spot the problem? So here I have content/drive. Here you can see my drive /Niger youth is not here. So let me add this my drive /Niger youth now. Hope I'm not performing magic. Oh. Hello. And let's run this now. So you can see now we've run this already. So because of my drive that is not there, so file path is very, very important to take note of. It's very important you note the file path. Hello. Okay, so you can always look through this code and see how you can proceed with checking your data from the drive. Okay, I don't know why this is hiding. Okay, so do we have any questions? So this is where we're going to call it an evening. Let's ensure we get to the office hours on Fridays within the hours of 9 a.m. to 10 a.m. for us to be able to catch up on the final part of the data science track. Okay, so do we have any questions? Hello, Vivian on the call. Welcome, Damilare, Kausarat, Makinde, Winnie, Lawson, Paul, Vivian, Abisola, and Adeyemi. Thank you for joining. Do you have any questions at this time?
I don't have a question no, for now. Please, are we going to get the voiced one, like the YouTube class you said you sent to us? Are we going to get it after today's class, probably tomorrow, so that we can practice?
No issues. You're gonna get it updated. Okay, just hold
Okay.
on a little while. Check your email. So do we have any
Okay.
questions? No questions? All right. So thank you very much for coming around for this evening's session. And please let us engage on the group chat. Okay? And do not stop learning. Do not stop learning. You still have a long way to go. However, you riding on the wings, you riding on the shoulders of those who has gone ahead will help to bring you to speed. Okay? So I wish you the very best on the journey. You can always reach out for support. So very big thank you to the sponsors, IHS Towers and the implementers of your foundation and Kratos Sustainability Consult Limited. I remain Abayomi Okunola, joining from NASA 84 Labs. Do we have anyone with a vote of thanks, comments, feedback? You can unmute, tell us your name, where you're joining from, how the class has been of great benefits to you. You guys should unmute. Mr. Lawson, all the way from Cyprus, we owe you. Thank you for joining. Okay, so if no more feedback or comments, let me stop recording.